All right, today we're going to look at congruent triangle postulates. And what these are is they are shortcut ways to determine triangles are congruent without having to show all 6 parts are congruent, all 3 angles and all 3 sides. So the first one we're going to look at is called the side, side, side postulate. And that says if all 3 sides have a congruent matching side. Okay? So when I look at this to check, I like to get myself a highlighter. If you have a highlighter or a crayon or a marker or a color pencil or something, I like to get 2, and I like to use 1 to note my sides and 1 to note my angles, because you notice in the next postulate we're going to be looking at angles. Okay? And then what I do is I mark on one triangle things that match the other triangle. So for example, I can see that the distance from C to A is 7, and that matches Y to Z. C to B is 8, and that matches Y to X. And then B to A is 9, and that matches Z to X. Okay? So I can see that I've highlighted all 3 sides of one triangle that matches the 3 sides of the other triangle. So I can use what we call the side, side, side postulate to write a congruent statement. These triangles will be congruent. I can start with the first triangle and say triangle ABC is congruent to triangle, and then remember order is important. So if I start here at angle A, which is between the 7 and the 9, I have to start between the 7 and the 9, so that puts me starting at Z. And then from A I went to B, so I went across the 9 centimeters to B. So from Z I'm going to go across the 9 centimeters to X, and then end up at Y. Okay? So again, if all 3 sides of your triangle are congruent, or are congruent to the 3 sides in another triangle, we can use the side, side, side postulate to say the 2 triangles are congruent. So we'll say triangle ABC is congruent to triangle ZXY, and we can say by SSS congruence. And the reason we do want to put this congruent, sometimes we forget to put that, but we want to put that because later in the year we're going to be looking at side, side, side similarity, or side angle, side similarity. So we want to make sure we're talking about congruence here. Okay? So let's look at the next one. For the next one, I have side, angle, side postulate. Oops, runaway highlighter. Okay, and so this is going to be 2 sides, side, side, and the included angle. Let's talk about what we mean by included angle. Okay, so I'm going to look at my 2 sides, and again, I'm just going to highlight one triangle. You can pick whichever one. I usually go with the one on the left just because it's left. I don't know. And find the things that match. So I can see I have a 6 centimeter piece that matches a 6 centimeter piece. I have an 8 centimeter side that matches an 8 centimeter side. Okay? Included means in between or inside, right? So it's included in both segments. Look at this 50. This 50 is the end of each segment. So it's touching both of them. It's included in both of the matching segments, the 50. It touches the matching 6 and it touches the matching 8. So it's included on both of those segments. Okay? So this is a side, angle, side similarity. Okay? When we write our congruent statement, remember order is important. So when I start with my first triangle, I can kind of pick the order. I can say GHJ or JHG or HGJ, however I want to do it. I'm going to go let's go GHJ. And that's going to be congruent to, and now the second one, the order is important. It has to match. So if I started at G, the end of the 8 centimeter that's not the 50, so the end of the 8 centimeter that's not the 50 is Z. And then from G, I went to H, so I went across the 8. So from Z, I'm going to go across the 8 up to Y. And notice H and Y are both my 50-degree angles. And then I'm going to end at X. Okay? And we can say that these triangles are congruent by the side angle side, or we say SAS congruence. Okay, let's look at the next one. The next one, we have angle side angle. So on this one, angle side angle, I'm going to have two angles and the included side. So last time we looked at an included angle, this time we're going to look at an included side. So when I look at my angles, I can see I have P is 60 degrees and it matches with Z. N is 40 degrees and that matches with X. And then I have a side that touches, it's included in both angles. It touches both the 60 and it touches the 40. So it's included in both angles. Okay, if I had picked this side, it would only touch the P, right? It wouldn't touch the N. Or if I picked this side, it would only touch the N, it wouldn't touch the P. So to be included, it has to touch both. And then it kind of looks like what it says, angle, side, angle, angle, side, angle, right? They're right next to each other in kind of a line. So these triangles we can say are congruent by the angle, side, angle postulate. So triangle, we can pick the order on the first one. I'm going to go P, Q, N. And then the second one has to match what we said. So triangle, if I started at P, which is 60 degrees, I'm going to have to start at Z for 60 degrees. And then Q is my unmarked angle, which I could figure it out, right? Because together those are 100, so that has to be 80. Q. And then N matches with, oops, not Q there. I lied. I should have Z and then Y. Z, Y, we want to make sure they're coming from the right triangle. Z, Y, X. So triangle PQN is congruent to triangle ZYX by, this one we're going to call angle, side, angle. So ASA congruence. Okay. When I look at the next one, angle side angle, or angle side postulate, so that's a little different than this one. It's still two angles and a side, but see how this side is in between the two angles, so we say it's included. This one's going to be two angles and a side that's not included between them. So two angles and a unincluded, or an unincluded side. So it's not going to be between the two angles. It can only touch one angle. So let's look at what that looks like. I have my two angles. R is 40. That matches with Y. S is 60. That matches with X. And then my side is only touching angle S. It's not touching angle R. The 8 centimeters here is only touching angle X. It's not touching angle Y. Okay? So this we call the angle side angle, or angle side postulate, because it's two angles and then a side that's not in between them. Triangle, RST, you can kind of pick the order on the first one, but then this order on the second one has to match. If I started at R, which is 40, I'm going to have to start at Y. And then I went to S, which is 60, so I'm going to go to X. And then I'm going to end up at Z. These are congruent by angle, side, congruence. Okay? So now I'm going to kind of make a little reference sheet at the top of these notes for me. So if you could print them out, this is going to be handy to keep near you. With my highlightings. So if you can print this out and you can have access to highlighters, this is kind of going to be a short little way to just reference this real quick. So side, 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 SSS. On one triangle, you're going to see all three sides will be highlighted and no angles. Okay? For the next one, side, angle, side, you're going to have two sides, and then where those two sides come together, that's the angle that you're going to be looking at. So it's going to kind of look like an arrow that's highlighted, and then the point where those two come together is going to be circled. Okay? Then for angle, side, angle, when I look at this one, I can see I have a side, and on each end of that segment, I've got an angle. So I'm going to have a segment highlighted, and then on each end of that segment, I'm going to have an angle. Angle, side, angle. And then the last one we talked about was angle, angle, side. So angle, angle, and then a side that's not in between them. So you're going to have two angles, and then the side is not going to connect your two angles. So you're going to have two angles marked, and then the side is not going to connect the two circles. Okay, and then you see there's still this HL here. We're going to address the HL in the next video. So make sure you tune in for the next video so you can see what that HL stands for. All right, thank you so much for watching.